Alright, so we just finished part 1 of this video. This is, AB 39. And now we're looking at part 2, which is integration. Integration. And here we go. So the big idea, if the derivative of e to the x is e to the x, then the integral of e to the x dx here is, well, that's just e to the x. But because there's no boundaries on the top and bottom, then we got the plus c. So here's how this is way different when we talk about u's. We have e to the u, but this du is related to that u in the sense that du is equal to the derivative of u taking respect to x. Okay, so we got to keep that in mind because du dx it's like taking the derivative of u with respect to x. You get the du. That kind of thing. Well, let's see how that plays out. All right, so the idea here is I see that there's a u. How do I deal with it? Well, let's work our way backwards. We know u equals 5x. And then I know that du dx, if I were to take the derivative of that, that would be 5. Okay, so good so far. Kind of. Because I look up here, I don't see a 5. Because if I were to make the first substitution, I'd have e to the u, then dx. Well, I need to change this out for du. So that means I got to multiply both sides by dx. Divide both sides by 5. What are we going to get? We're going to get 1/5 du equals dx. So I got to have a 1/5 in here. And this dx is going to become a du. Let's take those 2 steps back. Go one piece at a time. So this is going to become 1/5 e to the u, that stays the same, then du. There we go. So I got my 1/5, my du, and the e to the u. Now I'm ready. I'm good from here. So from this point, I can take the antiderivative. The antiderivative of e to the u du is just e to the u. But I have this 1/5 here. It's like a tag along. It's that constant multiple rule. Keeps on coming back. And of course, plus c. No prob, Bob. Let's keep doing this. All right, let's try some instincts. I'm looking at this, and I see that this is my u. U equals 1 minus x. So I'm going to make the substitution. This would give me 4 times e to the 1 minus x, but I'm not going to put 1 minus x. I'm going to put e to the u. And then I got a dx. Problem, u and x don't match. So now I got to get through my du dx. Well, the derivative of 1 minus x is -1. But I don't see a -1 up there. Alright, so what do I got to do? I got to do a couple things. First, let's get rid of this dx. Move that to both sides. Then let's get rid of this -1. That gives me negative du, or -1 times du, is equal to dx. Now I can swap out this dx with negative du. That'll give me a 4 and a negative, so I'm going to put the negative out in front of that. That's where that negative went. Then we have e to the u du. Alright, now we are ready because this e to the u du, that's just e to the u. And of course we're going to have a plus c on the end here. But this -4, that's just a tag along, and boom, done. Next. Okay, don't freak, alright? Don't freak out here because I know it looks like we're going crazy. You're like, whoa, 2x e to the x squared is like, oh, look at all those letters and 2's. It's not as bad as you would think because you know that this top exponent here, that's got to have something to do with your u substitution. So when I do this integral, I'm going to have a 2. I still got the x there, but I'm going to have e to the u and a dx. So now I got to get rid of this x, maybe the 2 as well, and the dx. Let's see what happens. Well, du dx, in this case, would be 2x. Whoa, that's like convenient. Super convenient, because now du is equal to 2x dx. So that's a straight out substitution. I'm going to take out the 2x and the dx, replace it with du. So those are gone. It's just du. The e to the u, that's still there. And this is like super easy. Now it's becoming just e to the u plus c. Of course, could I plug these back in with the u's? Yeah, I could plug in this u and this u and this u, but I know what they are. I already figured out what they are. I'm just kind of shortcutting stuff here. Next. All right. Again, it will work out. Just relax. 1 over x. So u equals, let's call this x to the negative 1. That means I'm going to have e to the u up here, but I still got down the bottom 2x squared, and I still have over here a dx. So let's take the derivative. Du dx of x to the negative 1 is going to become negative x to the negative 2, which if I kept going would be negative 1 over x squared. Check done. Okay, so we got stuff going on here. Negative 1 over x squared. So I don't see a negative in there. So if I start, moving stuff around, I could have negative du, if I can correctly use the letters here, negative du equals 1 over x squared dx. Now I see x squared in the denominator and dx there. That 2, no big deal. It's going to stay there. So now when I make my second layer of substitution, I'm going to have the e to the u. We're going to have this negative here, so that's a negative, and there's going to be over 2, or 1/2, you could say, and a du. So that negative over 2, that's just negative 1/2. That tags along. The e to the u du becomes e to the u plus c. This is awesome. Kind of easy. Not super easy, but very consistent here. Figure out what u is, balance your u's, substitute, balance again, and just make your way through it. No problem. Alright, we're getting close to finished here. Now we're going to get into some more complex pieces, but they're really not as complex as you would think. So let's give ourselves some workspace. So I'm going to vertical lines, put these in here. Okay, let's start with orange, just for fun. I know, and you probably know, that this sine x is my u. So that means u equals sine x. So then I'm going to take the integral. I have this cosine x, but I'm going to say e to the u, and then we got a dx. So I got to do du dx, see what happens. Du dx, the derivative of u. Well, if u is sine x, then the derivative of that is cosine x. And check this out. Easy. Super easy. Du is just cosine x times dx, which I have up here. So now I can take those out and replace them with du. So I'm going to have the integral. I got e to the u and a du, and then the antiderivative of e to the u du is e to the u plus c. That is so cool. It's like it was set up, ready to go. Way easier than you would have thought. Alright, now this next one, okay, I'll admit, not obvious. You look at it and you're like, really? Really? Okay, really? What do? I don't know. Maybe I do. But I'm going to try something. So here's my options. I can't really split this up into multiple fractions because there's only one numerator. There's one numerator. So unlike number 24, we're going to look at a different strategy for that one. But I see one numerator, two denominators. Okay, or two terms in the denominator, I should say. I can't really split it up into multiple fractions. What I could do, though, is I could try a substitution with one of these pieces and see if it gets me to the other. So I'm going to pick the one that's more complex because that tends to be, you know, the piece that's the u, because you take out the inside piece. Well, this kind of looks like an inside piece, this denominator. Let's see what that would be. If I said u equals 4 minus e to the x. Let's see how that would help me. Well, then if I were to take that out, I'd have e to the x on top, and I'd have over u, and then a dx here. Okay, I'm still kind of stuck here because I got these x's and u's, so now I got to get through my du dx and make that substitution. That's going to tell me if u is 4 minus e to the x, the 4 goes to 0, and the minus e to the x, the minus is still there, and derivative of e to the x is just e to the x. Oh, well, this is kind of helpful because if I multiply both sides by dx, now I'm looking at du equals negative e to the x dx, but if I multiply both sides by negative, I got my e to the x dx equals du. Okay, so this e to the x dx, that's going to come out, and I'm going to replace it with negative du. So there we go. That's our substitution. So I'm going to have negative 1 times du over u. Wait a second. I know this one. The antiderivative of du over u is natural log times the absolute value of u. And then that negative 1, that just kind of sticks around. Plus c. Do I really have to do anything else? No, because I could say negative 1 natural log of the absolute value of 4 minus e to the x plus c. This is really absolute value. There we go. But that's pretty much it. Oh, look at this one. Do these look familiar? Yes, they do. Because I know that these are like derivatives of each other. This was that whole Cinch and Koch pattern kind of thing where if I take the derivative of the top, that's going to give me the bottom. If I take the derivative of the bottom, that's going to give me the top. Okay, so which one is the actual u and which one is the du? So which one is the original, which one's the derivative? Because either way, it looks like I can make that substitution. Well, I don't know, who knows? There's some strategies I could apply here, but I'm going to just try and see what happens. Let's say I said u equals the top. U equals e to the x minus e to the negative x. Now, according to doing this earlier, we figured out that du dx, or the derivative of this, u prime, however you want to say it, would be e to the x plus e to the negative x. That would give me, multiply both sides by dx here. Then I would have, if I'm looking at this, I would have pardon me, how would this look? I would have the integral. It looks like I put u on my top, and on the bottom I have my du, kind of. That's kind of weird. It's like, is the du down here? But this is so confusing. This doesn't really work. So maybe I got it backwards. Let's try that. Let's say u equaled, let's do a new color here, just so you guys get a perspective on we're doing something different. That's not new enough. Red, u equals the other one. Let's say we went from the bottom, so that would be e to the x plus e to the negative x. Then its derivative, or u prime, or du dx, however you want to say it, would equal e to the x minus e to the negative x. Ooh, look at this. Now, that tells me that I'm going to have the integral of du over u because I can multiply both sides by dx. Here's my top, here's my bottom, top over bottom, du over u. And I know this one, it's natural log of u plus c. Natural log of u is actually natural log of the absolute value of e to the x plus e to the negative x plus c, of course. So there we go. That's that one. All right, strategy time. Ready? What do you see? I see one term. This is distributive property because in the same way that if you had one term outside times a bunch of terms inside, you would distribute it. Here, if you have a bunch of terms inside times one term on the bottom, you would distribute it, dividing into each one. So I'm going to do that here. I'm going to split this up into 3 different fractions. So let's do that. So the first one is going to be e to the 4x over e to the x. The second one is going to be 2e to the x over e to the x. And the third one is going to be 1 over e to the x. All this dx. Well, I got more I can do here, if you think about it. Because e to the 4x over e to the 1x, that's really, simplified e to the 3x. This e to the x for the second term, that just kind of disappears. It simplifies to 1. And then the last one is really e to the negative x. So I'm taking the integral. But I'm going to do it of all 3 of these because each of these has a different method. Well, not a different method, but slightly different values. The first one, e to the 3x, I'll call this u1 is 3x, and that means du dx 1 is really 3. So flipping stuff around, 1/3 du1 equals dx here. So I'm going to have my substitution is going to be 1/3 e to the u du for the first one. Second one, thankfully, that is like super straightforward because the antiderivative of 2 is just 2x. So this is going to be just the antiderivative of 2. I haven't taken its antiderivative yet, but I will momentarily. Plus the third one, e to the negative x. Well, here, my other u then is going to be negative x, which means my du dx is going to be -1, which means I'll have negative du equals dx. So here, I need a negative to go in here. All right, put it all together. Antiderivative of the first one, we're going to have 1/3 e to this u, which is e to the 3x. Second term, 2x. Too easy. Next term, minus e to the negative x, because this time u was negative x here. And of course at the end, plus c. That was a lot. Quite a bit there. Quite a bit. All right, let's apply some of this. Now that we got some of these combo plays done, let's use the pieces. Find the area bounded by the curves and lines. Oh my goodness. All right. So we got y equals e to the negative x, y equals 0, and x equals 0, x equals 1. So if I'm thinking about this, first I got some vertical lines at x equals 0 to x equals 1. I got this line, y equals 0. I think the other one's above it, but let's just check. This is really the same as y equals 1 over e to the x, which is still a positive number of some kind. And as that x e to the x gets bigger, this gets smaller overall, so we're looking at something that looks, like this kind of. So we're trying to find this area. Let's graph all that and just confirm. So I'm going to go to my y equals. We're going to graph the line 0. Or we don't really need to graph line 0. We know where that is. Let's graph the line e to the negative x. That's second natural log. We're going to raise it to the negative x. Our window is going from 0 to 1. That's already happening. And that y value, that's probably fine. So there we go. I got to find the area under this curve here. Between this curve and y equals 0, the x-axis. Which is what it actually does when I just, try to do the actual area. So wait a second. Let's set this up. That means I'm going to have the integral of e to the negative x from 0 to 1. Well, this needs to have a negative in there, but it doesn't, but it needs one. So when I say u equals negative x du dx equals negative 1, that means negative du equals dx. Okay, we've done that enough times, we should kind of be able to follow that a little bit. But that also means that a is really negative 1 times that, so that's going to be 0. And b is going to be negative 1 times 1, which is negative 1. So we're going from 0 to negative 1. Those are in terms of u, because before they were in terms of x. And then we have negative e to the u du. Well, that's going to become negative e to the u, but we're going to evaluate that from 0 to negative 1. Okay, so I plug in the top one. That's going to be negative 1 e to the negative 1, but negative, minus negative e to the 0. Well, that would just simplify to, what would this be? Negative 1 over e plus 1, or 1 minus 1 over e. Okay, so can I confirm that with a calculator? You betcha. Let's calculate this. Second, calculate area. Oh, that's not what I want. Second, calculate area from 0 to 1, and I get this number, 0.632. Let's see if that's what it is when I just type it in here. So what was this? 1 minus 1 divided by second natural log e dx. We can just say e. 1 divided by e. Boom. 0.6321205. Did we get, oh, yeah, we did get the same thing here, but we didn't see it. So what is it? It equals 0.632 something, 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 something. Cool. Oh boy, we got crazy things going on here. So we have this x equals 1, y equals 0, and this function here. Let's see what that function does for us. E to the x over 2 plus e to the x. So we're going to have e to the x all divided by, now on the bottom here it's going to be 2 plus e to the x, I believe you have. Second e to the x, x, close it off, graph. Alright, so here's my graph. I know that I stop here at 1, and the line y equals 0, but the crazy thing is, does that equal 0 back there? So I need to unzoom a little bit, at least in my x values. So let's go from like negative 1 to 1. Where does that take me? Well, I'm not quite there. I need to keep going back just a little bit more to see when that actually crosses. So now I'm going to go back even more, and I'm going to drop down in the y-axis just a little bit, just to be sure that we're actually getting what we need. Go to negative 1. X minimum negative 2. Alright, now let's graph this, see what we got. Oh, this is kind of weird. So do we ever cross? I don't think so. Because we stop here, but do we actually get below that? Did we type everything in correctly? Yeah, I'm pretty sure there. So the question is, does this ever equal 0? That would mean that e to the x would equal 0. And that actually doesn't happen. Not at all. So for number 20, we can't do that. Not possible. At least not with the calculus that we know so far, because we can't figure out the area from, here to 1, because this curve that we were seeing, it goes down, but it never actually stops. This is always open. There's no left boundary that connects the top and bottom. It's got to connect the top and bottom. Or maybe I'm not seeing something, maybe I plugged it in correctly, but that kind of makes sense with that type of function as well. So, not possible. Alright, this next one, trig. Ooh, that's interesting. So let's see what happens with that. We got this crazy function, e to the x sine e to the x, x0, y equals 0. So that means we're talking about first quadrant here, figuring out this function, and hopefully it's going to close off on each axis there and give us kind of like, I don't know, a general boundary where we can find this area. So I'm going to take this back, because I don't know exactly what it looks like, but I'm going to find out. So let's erase this. Boom. There we go. Okay, so now we got to do some typing. We have this crazy function here. This function is e to the x. Okay, so that's the same. Times sine. Now we got sine. So we got sine second natural log e to the x. Boom. I can delete that, delete that. There we go. Let's graph. Do you see anything happening? I don't really see anything happening here. Whoa, that looks really tiny down there. Let's see what that's doing. Looks like I need to get really close. So I'm going to get close from like -1 to, well, we know that this can't be less than 0. And the y minimum would be 0. Y maximum, how about 0.2? That looks really close to the ground. Let's see what this is going to show me. Alright, there we go. So again, what the heck? This is not really working because, again, so I'm going like from 0 to 1 here. If this goes back down, then that works. So let's see if that goes back down. I need to go out further. So let's say my x maximum is like, I don't know, 10. Nope, it doesn't go back down. Oh, that's kind of weird. Bunch of asymptotes there. So this one, again, no solution. That's just crazy. No solution. Not possible. Because our picture, it says x equals 0, y equals 0. So when I'm looking at this, I see this curve. There's no right boundary. So those problems probably have a typo or something missing in there, like x equals 0. Or, oh, this one said x equals 1, but it needed an x equals 0. This one says x equals 0, but maybe it needs an x equals 1. Let's check some other stuff, see if we can find those. Find the volume. Ooh, volume! In the first quadrant, region R bounded by boom this and boom this, rotated about that. X-axis. Okay, so we got to graph this. This is volume, volumes of rotation. So when I go to my y equals e to the x, this is going to be second natural log e to the x over 2. So we have x divided by 2. There we go. So I'm going to graph this. I'm going to go out to at least 2. Am I? Well, it's going all the way out to 10. I only need to go out to 2. My y values, I have no idea how far it's going to go. Let's go up to 2, see if that works. It actually goes a little bit higher than that. And I need to go even further back. Oh, first quadrant. All right, first quadrant. So that's helpful to me. So I need to make this go even taller. So let's look at my window. Instead of going from y equals 0 to 2, I'm going to go from y equals 0 to, let's say, 5. That's doable. All right, so here is our region right there. And here is my axis right here. So I got some questions to ask. Is there any empty space? Am I attached to that axis or am I detached? Well, I'm attached. No empty space, which means I don't have an inside disk to subtract out. There's no negative space. So I'm just going to have the integral of pi times my radius squared, dx in this case. And I know that I start here at 0, and I'm going up to x equals 2, so I'm going to go from 0 to 2. The only thing I really need to figure out then is what's my radius then? R1. Well, it's from here to here. And if you were to think about this, I know in previous videos I usually say like start with your axis minus your edge kind of thing. And we could have done this edge minus axis. It really doesn't matter. But we got these two lines. The axis here is y equals 0. That's our x-axis. And this line is y equals e to the x over 2. So we're going to have e to the x over 2 minus 0. Or just e to the x over 2. So that's kind of cool. All I got to do is integrate that, but that's squared. I could do this by hand because this is going to be the integral from 0 to 2 of pi times e to the x over 2 squared. But look at this. X over 2 squared is really just, hang on, we're getting there, e to the x dx. And what's the integral of e to the x dx? What's the antiderivative? E to the x. And that pi, what happens to that? That's a constant, so it kind of tags along there. And then we're evaluating from 0 to 2, which means we're going to have pi times e squared minus pi times e to the 0, which I could factor out the pi. And then I got e squared minus 1. Check. Done. That was awesome. So cool. So what did we do? Let's trace our steps here. First, we drew a picture. Picture. That was step 1. Second, we looked at this question here. Question, is it attached? Do we have emptiness in there or not? Well, there was no emptiness, so we just needed one radius. We didn't need the inside little radius as well. Then third, figure out the radius. And then fourth, plug it in. And then fifth, take the antiderivative and evaluate it. Check, 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 check. Let's see what else we got going on. Ooh, this is where it gets crazy. Crazy interesting. I'm not even going to look at the formulas to memorize them. I'm going to just look at this and do it the long way. Kind of the long way. It's not as long as you would think. So I look at this and I see a problem. X in a exponent. That's a problem for me. I don't like it. It doesn't help me. In fact, it hinders me. So what I would do then is I would take the natural log of each side. Natural log of y equals natural log of 5 to the x. Because now that exponent I can drop down. And then I'll have natural log of y equals x times natural log of 5. At this point, natural log of 5 is a constant. But I can take the derivative implicitly of both sides. On the left side, I'll have 1 over y times dy dx. On the right side, I'll have the x goes to a 1, and I'll just have natural log of 5. I'm going to multiply both sides by y. Then I'll have dy dx equals natural log of 5 times y, which is really natural log of 5 times 5 to the x. Boom! There we go. All right, same process, different functions here. So I got to get this to drop down. That means I got to take natural log of both sides. So I'm going to drop this down here. That's going to give me natural log of y equals x squared minus 2x times natural log of 3. Natural log of 3 is a constant. Ignore it. It'll tag along. Take the derivative implicitly of each part. Again, we got the 1 over y dy dx, because that's the derivative of natural log of y. We've done that before. Derivative of this piece here, x squared minus 2x, becomes 2x minus 2, and then this constant still tags along there. So now I got to multiply by y on both sides. And I'll have the derivative dy dx equals 2x minus 2 times natural log of 3 times y, which in this case is 3 to the x squared minus 2x. Alright, number 25, the finale for the day. What do we got to do? IC product rule and natural logs. So let's see how that works with what we are doing. So if I take the natural log of each side, let's do that first. Natural log of y is on this side. Then on the other side, it's going to say natural log of x times 6 to the negative x. So I got to split that up first into two terms. So natural log of y equals natural log of x plus natural log of 6 to the negative x. Now that negative x can drop down, and I'll have natural log of y equals natural log of x minus x times natural log of 6. Natural log of 6 is a constant. I'm going to treat it like a constant now. Let's do the implicit derivative all the way across, implicit differentiation. Derivative of natural log of y is 1 over y dy dx. Derivative of natural log of x is just 1 over x. And then we got minus x times this, the derivative of x is just 1. So that's really just minus natural log of 6. So now I'm going to multiply both sides by y. Get rid of it over here on the left and multiply it over to the right. So dy dx is equal to 1 over x minus natural log of 6 times y, which in this case was x 6 to the negative x. I didn't even have to do product rule because I was able to split it up here. I could have, but I didn't have to. It was very convenient. Alright, so we are done. This was crazy. This was super crazy. But go watch it again and enjoy it, because calculus is fun, especially when you're good at it, which means you need practice. So, good luck. See you later.